Not able to go on internet. You're not able to go on. in. I enable instance. I'll give it a second. All right, I'm going to try. All right, how's everybody doing tonight? As you can see on the overhead, I don't know if you saw on our social media, the resume workshop right after class tonight in 1322. Welcome for all to be open. It's open for all. It's going to go over resume building, stuff like that, job seeking help, things like that. So you're welcome to go. Room 1322. Also on the MyRC website, there is still a posting for in Rock Valley College in the jobs section for programmer. So if you know somebody or yourself are interested in programming, definitely avail yourself to that. And so just go to myrec.org jobs and find out more on the programming analyst IT position, ranging 49,000 through 62,000. All right. Next. I'm going to show you the thing we're doing with technology. Each semester we have different events going on. One of them is Girls Who Code, and this semester we're focusing on coding with drones, controlling drones with code, or controlling Internet with thing devices with drones, and robots with drones. We started out with robots with code, and then the first one we're starting out with is controlling drones with code. Here's a program that they're using called Drone Blockly. On the right is JavaScript. In the middle portion is a blocks that say for the drone to fly up 60 inches or 80 inches, flip forward, fly up 20 inches, or flip up, fly up 20 inches, flip backward, fly backward 20 inches, fly up 20 inches, yaw right 360 degree, which means it's going to do a full rotation, hover for 5 seconds, and land. And here's the video of what they're doing. Okay, here's the code. I'm going to do the command here launch. Downstairs when we did it. Until I have 80 inches. We'll flip forward. the 360. Pause for 5 seconds. And then so some of the stuff we're doing. Again, the drone we're using is DJI's Tello drone, and I'll show you what that looks like. So it's not a real expensive drone. It's a good one to start with if you're just learning. If you're interested in drones and want to not spend an arm and a leg on a drone, but it's a real steady drone to fly. This is an EDU version, one we're using. Comes with all the code to control it. So if you're not comfortable, which the reason I like it is they're learning code, but at the same time, they're not going to crash a drone because the code is flying the drone. Now the code could crash it, but they're not going to crash it. And so we can do all the tricks and manipulations you would normally do as a controller, but automated with code. And so anyway, you can get these at DJI store, or Apple Store sells them as well. I recommend the EDU if you buy one. It's really best for indoors only. I have flown it outdoors, but with the wind around here, it does work outdoors, but it works better indoors. It's a great one for flying indoors. As far as other products, I recommend once you get that one, say you advance and get good at that level of drone, the Spark is the next one I recommend. A little bit more expensive, but comes with a oh, by the way, the battery on the one that I just showed you lasts 13 minutes, which the average cheap drone is about 6 to 8 minutes, and so it's about double that. This drone here, the Spark drone, it lasts about 45 minutes for one charge, and it'll go up as high as you want it to go, basically, and it will go outside. I've had it up as high as 400 feet. Because that's the FCC cap. Wink, wink. I've had 100 but I've had 400 feet as a cap for FCC in the U.S. But it'll go thousands of feet high because it's controlled by satellites. And so anyway, this is the next one up, which again, not real expensive for a really solid drone. The way it works is when you connect to it, it has a controller. You can use your phone, tablet, whatever, to connect to the controller. And then the controller connects to satellites, and the satellites connect to the drone. And generally on any moment, you have anywhere from 11 to 12 satellites you're connected to that you're controlling the drone with. And so in the US and SEC regulations, say you're supposed to be within line of sight of your drone, I mean, visually see at all times. But this one will go out of sight if you wanted it to. One of the cool features of this and the one I just showed you all the DJI drones is if God forbid if it goes out of the range or you lose connection, if it loses connection with the satellite or whatever, it'll automatically come back to home base and land instead of just continually flying off into the space. And so next one that I've got this one too, and then the one I'll show you I like is, and I've got this one as well, the Phantom 3, which I don't have the Phantom 4, but it looks like this Phantom here. This one I don't fly as much anymore. It's a lot bigger. Spark does everything I need it to, but this one I do fly. It'll handle heavier winds. I've had it in winds up to 45 miles an hour, and it just sits there and goes steady, doesn't move. And so it's a pretty solid one. These are the ones that they use in like first responders use to go into fires and things like that and assess things. And so battery life's about the same. And it does have a regular RC remote that connects to satellites, and the satellites connect to That, but as you can tell, a lot more expensive than the other one. But the products I recommend starting with is the one I just showed you first, which is the Tello drone. And it is a really good one to start out with, I think. And it comes with some really, they actually have a unique feature. I've not tried this yet, but they have a feature that where you can tether these, and they dance as one unit. Let's see if I can find that video. It's pretty cool. Let's see here. Basically, you can control one drone, multiple drones with one controller, basically, is how it works. I think this might be the one. There it is. She's using Swift, an iPad, the iPad app Swift, which is coding, controlling it with code, Swift. And you'll see another person join here in a second. Those little pads are what they can use to do the swarming, is what it's called. Swarming, S-W-A-R-M. You can have up to 6 or 8 swarming in one controller. And you don't play the keyboard like a piano, by the way. It's just dramatized. But we'll do that. We'll do the swarming. I can't wait. I've got more of them coming where we can do swarming. We can connect one app to multiple controllers and then use those mission pads. And it'll basically, the drones will synchronize, do like a synchronized movement with amongst the drones. So anyway, if you know some people that are interested in drones or you yourself, recommend the Tello EDU version. It's a little bit more expensive, but it comes with those mission pads that you saw in the video just a second ago, and all the stuff to get started. You can control it Python, Swift, Drone EDU, Tello EDU, blocks. Thus far, it's what you can control with. So anyway, thought I'd share with you. Everybody thinks drones are pretty cool, I think, probably. You know, different. If you've never had them before. But if you've had them before, you probably crashed them many times if you have tried drones before. And the nice thing about the EDU one is, with code anyway, it's less susceptible to crash. Okay. Oh, the other thing I wanted to show you in the news was, anybody been to Austin, Texas before? Been to Austin, Texas before? I'll show you this new building Apple's going to be building in Austin. Because the cost of living in Silicon Valley, as you can imagine, is skyrocketed. Let's see, see if I can find that one as an image on it. That's what it's going to look like right there. $1 billion in Austin, and it will, let's see, it will, as far as jobs, it was crazy on the jobs. Let's see, they're going to get kickback from Austin for sure. 6,200. They already have 6,200 employees in Cupertino. The Austin one that they're planning on building, and already have the building permit and everything, on 133 acres. Expected that it'll be the city's largest employer with a workforce of 5,000 employees at a capacity of 10,000 more to add. So it can add up to 15,000 employees at one location. And by the way, this is mimicking the one in Cupertino right now. They just built this one not too long ago. Before Steve Jobs passed away, that was the the spaceship, the Apple spaceship that was built. In the middle of it is vegetation, trees, gardens. There's not one flat piece of glass around the entire building. It's all circular. And then all the offices are faced outward towards the window, and conferences and things are faced on the inside, if I'm not mistaken. Anyway, the largest, 5,000 employees up to 10,000 more, they will get a tax break. It shows, and they looked at other states, and the reason it shows Texas or Austin was for tax purposes, and they had the best kickback for building it there. And if you've never been to Austin, it's probably it's already busting. It seems already Austin is with technology companies. So anyway, I thought that's in the news. It's been out a couple months, but I saw it last night. I thought I'd mention it to you because I imagine most of you have not seen this building that is pictured here. And this is the one that, again, just like the one in Cupertino that was built. So we have a few students, by the way, working in Cupertino at that location. But the cost of living evidently in Silicon Valley is triple what it used to be 2-3 years ago. So I thought I'd share that with you. All right, so tonight we're going to go over Chapter 6. And in the lab this Thursday, we've got access point. We're going to be doing access point or spoofing with our Mac, with your MAC address on your NIC cards. We're going to mimic it as it would be done in a Wi-Fi scenario. We're going to be using Wireshark and an app on your local PC that we'll download called MAC Address Changer, which what it does is it will take your MAC address and spoof it along with your IP address. And we'll talk about what the purpose is of spoofing on Thursday in more detail. But basically it's to be able to infiltrate a network. Hackers use it to infiltrate a network instead of to bypass security, is how spoofing works and why it's popular amongst hackers. We'll also talk about ways to thwart it on a network for this not to occur, or less the likelihood of this occurring. Review questions as always, and quiz as always for this week. And looking ahead a little bit, next week, week 7, we'll be doing Chapter 7 and steganography, which is the art of hidden writing. That one you will hide data in images and talk about ways that's been used in the past with terrorist groups, with hacker groups, and also positive uses of steganography as well. But it's been used for centuries, before computers actually, the art of hidden writing, during wartime and things of that nature, where they'd invisible ink and things of that nature. And then week 7. No, the steganography. Week 8. This is the week before break. We'll be doing on risk identification. In this one, you'll be looking at the RVC account password policy and figuring out a couple things, what assets are a part of that, any threat agents against your personal account password, any things that you could find vulnerability-wise you'll be looking at as well that week. And then week 9 is after break. You'll notice the date changes a week. We're missing a week here because of spring break. Right after spring break is when I'm using that time, that week anyway. You'll be meeting Tuesday, but Thursday you'll be doing staying at home to start working on your research paper, creating your outline. And so there'll be no face-to-face that week. And there's a little Prezi I have you watch, a YouTube I have you watch, and then quiz and review questions that week are optional. So that's a little bit jumping ahead, a few weeks down the road. I wanted to stop at the week 9 because that's a pivotal one on your paper, which I know everybody's already started on your paper, so it's probably no brainer there. We're about halfway through or something on it, or 3/4 way through. Anyway, just joking. Okay, so let's go ahead and go to the chapter 6 content we're going to talk about tonight, and look at the different ways to secure a network through security devices on a network. So whenever we're talking about security, not all applications are designed with security in mind. So the network itself must provide the protection, if that makes sense. So an example, you go to work, I go to work, I bring my phone to work, right, like everybody does. The company's not in control of my phone, right? But do I connect to the Wi-Fi in my network? Definitely, I do. Okay. Now, granted, the Wi-Fi I connect to is an intranet Wi-Fi, meaning if I did have a VPN on my phone, which I do, I can remote in and get access to things. So because of that, the rules in the firewall need to be set up to where it protects devices like mine that connect, and vice versa. My device is protected as well from attacks, from security protection within the network. And that's what we're going to talk about tonight. There's also weak security, how it will invite attackers. We talk a little bit about honeypots, how they're used in the network, and some of the ramifications of that. We'll talk more about that this semester, show more on what honeypots are. How the building's designed can also be aspects of security, from proximity doors to alarms and things of that nature, motion sensors. So when it comes to standard network devices, security features found in network hardware provide basic level of security. Like an example, Wi-Fi access points. You are forced now, if I'm not mistaken, on access points to set a password of some type at some level of security, but it's usually basic level. It's not really the most stringent level of security. Then the next one that we're going to talk about, we talked about this in my 110 class the last few weeks, is OSI, which is the Open Systems Interconnection. It's a model in networking designed to illustrate how networking protocols work in a network, basically. It's just a model that how data is handled. OSI breaks down the layers of networking into 7 different layers. Each layer can talk to layers above it and below it. Here's the 7 layers. You have the application layer, which is layer 7. It's the top layer. It doesn't use an application, but it works with applications. So an application would be like Chrome, or would be like Firefox, or some game you have on a computer. Some database you might have. It provides services for application. Next is layer 6, presentation layer, concerned with how the data is represented and formatted. It's used to translate that data. So when you're an Eagle and you logged in tonight, it authenticated on the application layer, and you say you put your username and password in, it encapsulated that data in the presentation layer. And then layer 5, the session layer, allows 2 parties to talk one to another continually. So in Eagle's sake, it's continually talking to the server in this layer that you are connected. It keeps asking, are you connected? Yes, I'm connected. Are you connected? Yet continually does that all the time in this session layer. And then the transport layer, layer 4, is responsible for ensuring error-free data during that authentication session we're talking about in Eagle, that it's unintended or untethered and error-free. Layer 3, the network layer, picks the route for the packets to take. Not always the fastest, but the most sure route. So in this example here, I'm talking about Eagle. It's authenticating with the server your username and password, and it's finding the route to that server and back. Layer 2, the data link layer, is responsible for dividing data into different packets or cabooses, like a train. And so a lot of times it'll, every time it'll take say your data packet is 5 megs, we'll say. It'll take it, and this is a crude example, and it'll split up that data packet into 5 1 meg data packets, and then it'll send it across the network, and maybe this will go over here to this router here, this will go over here to this router here, this will go over here to this router here, this will go over here to this router here, this will come over here to this router here, and then the destination is a server. All of these destinations will end up and put back in order as it was sent to the Eagle server of your login information. That's done in this layer, which is the takes the network layer, then the data link layer, responsible for dividing that data into packets, and its duties, as I wrote up on the board, is to split it up and retransmit them if need to. So if one of them dies during the transmission, it'll retransmit it. And then the physical layer, this layer is to send signals to the network and receive signals from the network. And this would be your NIC card layer and your Cat5 layer. So hubs, those are dummy generally. They're dummy devices, meaning first come, first serve. We did a LAN lab in my 110 last week, and it's a question that came up, the difference between a hub and a router. Router is a smart device where it's routable. You can configure it with rules. A hub you don't configure. It's a dummy device. So the first usually has four to how many ports on the device, at least 4 generally. And you can connect up to 4 Cat5s on those hubs to connect to one another. It's does not read data passing through them. It's literally just a conduit for your network to talk on. It's ignorant of data source and destination, doesn't care, it's dumb, okay? It's literally just a brick device to communicate your data that you're connecting to that Cat5, if that makes sense. Rarely used today, but I have an issue with that. We use it a lot in networking still for setting up small LANs, small little test areas and things of that nature. So we use it quite a bit still. Linksys, by the way, D-Link, Linksys is the 2 most popular companies that still sell hubs, very popular still. Switches, ones at the end of your table. Those can be our smart devices that are configurable through a console cable to upload rules and things of that nature, whether it be for port rules to IP range rules. And it can also, it is a better layer or better device of security than hubs because, again, they can be configured. So whenever switches are used in place of hubs in a networking scenario and it sees a foreign IP address, it can actually block it from being used. You can actually whitelist in a switch that only these IP addresses are allowed. If it sees a foreign one, it doesn't allow it, which you cannot do in a hub scenario. Network administrator should be able to monitor traffic, traffic monitoring methods, port mirroring, network tap. We've already used a couple times in here. Network monitoring. Wireshark is an example of network monitoring, continual network monitoring of your network. So here we have an example of a computer on the network that's continually in IT, maybe just for monitoring, and it has Wireshark running all the time, or some other software running all the time to do port monitoring, IP management monitoring. In the IT brains center, there's multiple TVs on the wall that is constantly pinging all the servers. And when a ping becomes slow, it can put a red dot on that server and alert techs of that server going down or having issues. And they could just right-click on that server on the screen and restart it. Generally is the normal thing that occurs during that. Or they could do a filtering monitor to figure out what traffic's going on there. So here just has one switch at the top, right underneath the router, that's used to just monitor network activity. Now, this can be used in an IT scenario. It can also be used, hackers do this as well, where they get into a port, regardless what port it might be, a physical port like this or a Wi-Fi device, and they can use the same software to filter traffic and to see the valid IP ranges and things of that nature. And that's, how they get into the network. Here's what's called a network tap. Network tap actually can be a device like SonicWall is a popular network tap that basically filters content on your network, filters web activity, filters web content, and can block things as people try to visit or whatever. You'll notice it's in between the firewall and the router on purpose. And generally, these are appliances that are hardware appliances like SonicWall, like Barracuda, as two examples. And Cisco has a number of them as well. Meraki's one that's used for mental management, things of that nature. You can do traffic monitoring, things of that nature. So, type of attacks on a network, a number of them here is 5 popular. We've already done one in here already, the ARP poisoning. This Thursday we're doing the top 2, the MAC flooding and MAC impersonation. Actually, the MAC impersonation we're going to do Thursday. Flooding is where you basically find out, an attacker finds out switch's address and pushes a fake MAC address to that, forcing it to act like a hub, sending packets to every single device. It's uses a switch that can close ports to many MAC addresses at one time. MAC address impersonation or spoofing, it's also called, is if 2 devices on the network have the same MAC address. A switch maybe send frames to each device at the same time, and the attacker who has a spoofed MAC address is getting the same data as a real computer on the network that has the same MAC address. And again, you can use any filtering software to figure out MAC addresses on every computer on the network. It doesn't take long to figure that out. Or you can just ping an IP address and find out the MAC address as well. Configuring the switch that only one port can be assigned per MAC address is a way to harden a network to where it does not allow spoofing. So if it sees more than one MAC address out there, it'll block the second one. The first one's going to be the real one it's tied to. Second one it doesn't allow. ARP poisoning. We did that last week. The attacker sends a forced ARP packet to the source device, substituting the attacker's computer MAC address. Security defense on this, you can use ARP detection. Barracuda is one I mentioned earlier, SonicWall, Cisco hardware as well for ARP detection, as many appliances for that as well. Port mirroring is where the attacker connects his device to the switch's mirroring port. Security on this one, or to harden it, would be secure the switch in a locked room where people can't access those switches. Network tap, connected to the network, intercept frames. Also, security on this one is keep network connections secure by restricting physical access, like in all around the building, any Cat5 ports we have, RJ45 ports we have, we can put locks on them to where folks can't access them because they're locked up with a physical lock. Routers. This is on the layer 3 of the OSI. It's a smart device to filter. It's generally the first line of defense coming into the network to filter out specific traffic types from, let's say, you don't want to have FTP traffic on your network. You can block that. Block port 21, most popular port for FTP. Wouldn't allow it. Maybe block, I don't know, other ports that maybe other messenger softwares use or gaming software uses. You can block those as well. A lot of the gaming games will actually use certain ports. Like I remember in high school, it was Counter-Strike used 4 or 5 popular ports. The game would itself. And the easy way to block it was to block those ports from being accessed within the network at this level, the router level. Load balancers basically help evenly distribute work on the network. Advantages of load balancing is that it can take the breadth and the pipe that's coming through the network and balance it amongst all the network traffic. It can reduce downtime. Again, Cisco can load balancing devices as well with its switches as well that can be used, and also through routers. Load balancing can also be achieved through software or hardware device called a load balancer. Security advantages of load balancing: it can stop attacks directly to a server because it can mask a server's IP address to be a fake one, okay, on purpose. So an attacker thinks a certain IP address is directed to a fake one, so it's not going to really do anything. It can detect, prevent denial of service attacks, and then some can deny attackers information about the network, meaning it can disallow pings on a web server. So specifically, when it comes to network security hardware, greater protection than standard networking devices when it comes to security devices on a network. Firewalls will be one. There's hardware-based firewalls or software-based firewalls. Firewalls built into Windows operating system, Mac operating system, Linux operating system. But then also you can buy appliance firewalls that connect to the network that have to be configured on what's allowed, what's disallowed, what's accepted, what's not accepted. And one of the apps I always recommend talking about firewalls to play with at home is, if you've not played with it before, is Zone Alarm. It's a free program. It's free and paid both. But Zone Alarm is the reason I like this one for students to look at, even if you don't maybe use it after you play with it at home, is it will show you every single packet that's coming through your computer that you need to allow or disallow. And you'll be amazed at what, kind of like when we did the lab last week, where I showed you when the student was browsing the web, and I showed you Kane, all the stuff happening on the website, and he was just literally sitting there on the website, remember? Wasn't really doing much, and all this stuff was just coming through. Zone Alarm will show you that. And again, once the way Zone Alarm works is you have to train it to allow and disallow certain things that it comes through. But it's a kind of a cool way to see traffic with your computer just sitting there doing nothing, just connected to the internet. That's why I tell students is, just because your computer can stay on 24/7, 365 days a year doesn't mean it needs to. Because the hackers' most opportune time to infiltrate a network is between midnight and 6 in the morning. Because that's when generally most people aren't using their computers at home and at work. That's why most places I worked at, and even present day, we tell all users to shut down their computer at night when they go home. Shut them down. It's less likely to be hacked if a computer is on. In fact, it can't be hacked if a computer is off. Impossible. Do I now? Oh, like run processors or something? Yeah, there's going to be times where certain computers in IT are going to be needed for that, but not 100% of computers in business are need to be turned on for that purpose. You know what I'm saying? Generally. Right. Mm-hmm. Right. Yeah, I'm talking about companies, I guess, that literally have a time where it's a 9 to 5 type company, to where everybody goes home at 5 p.m. and there's literally nobody in the building after that time, and there's no processes running on their computers for any purpose. That's the time I'm talking about, where you literally should be a rule to where folks, a procedure rule where people know to shut their computer down at night. And it does elongate the hardware as well. It's, even though computers are made better than they were 5 years ago and last longer, that doesn't mean we can just, just waste energy, even if we don't get hacked, for 100, 200 computers every night being turned on. So, again, it's an energy thing as well, you could say. You could argue that as well. So energy, safety, again. But even at home, most people keep their computers on 24/7 as well. I have a few that I keep on. One is for a web server host, but I have one that I keep on, I'll just be honest, that I don't use for much of anything. I very rarely turn off, and I probably should turn it off. There's no reason to have it on every night. Yeah. Mhm. Yeah, you have to have a separate package or a package from your ISP to do that. Like a dedicated IP address. Huh? Yeah, you have to have a certain package. Yep. And you can buy that, but but yeah, most users don't need that. They're not going to have that. So, but no, best way to, besides having your firewall set up and configured properly, hardware or software, is if you're not going to use it, it's not going to be in use, to turn it off. Not only that, but some applications or just Windows operating system itself, after a certain period of days, will increasingly get more sluggish the more you have it on doing stuff. Like if you're really using it for work and it's really being used a lot, the system memory, we'll say, can get depleted, and it can get depleted to the state to where stuff doesn't work. Right? I've even seen depleted on people's computer where literally applications start getting red X's in them because they can't even load an image on a piece of software, but they've had it up for 2 weeks or something. So, anyway, best to, in those cases, in every case, to restart every night just to save security, being green, being better with energy, stuff like that. So this example here shows a firewall in most locations. You got your web connection coming into your internal router, your internet router. We'll say for most companies here, it's going to be through Xfinity Business Class or Comcast Business Class or whatever, Verizon. Then right after that, business router will then become the company's firewall. The company's firewalls and configured. Let's say, for instance, this computer here on the bottom right is the company's web server. This is the company's web server right here. And we'll say the name of the domain is abc.com. It comes through the router, and it sees abc.com coming through this router because the ISP, whenever you have a business class ISP, you get up to 3 external IP addresses, hard-coded, meaning they don't change. They're your IP address that you can use for whatever purpose. Well, let's say you have your own website, like I said. You bought the domain through GoDaddy, we'll say. Purchase your domain for that. But in GoDaddy, you have to configure what's called the DNS for that website. So what you do is you go to GoDaddy and put in that external IP address, which is what Comcast gave you or Xfinity gave you. So when people type in abc.com, GoDaddy redirects it to that external IP address you put in there, hits that router right there. On the router, you configure it. When it sees this IP address, it goes to this local IP address here on your network, which is your web server. And that's how it works. So, but those rules are set up in here in the router, if that makes sense. Okay. And for congestion's sake, you can even have it load balanced to where you have multiple web servers. If you have a large business like Amazon, maybe, which they have a lot of customers coming in online, to where they will literally have multiple servers that will kick that router will have many IP addresses to go to from Amazon.com, depending on the time of day, depending on the congestion. And it can go to any number of web servers to host the same servers, basically, if that makes sense. So firewalls have a couple actions, 3 actions actually in a firewall, whether it be hardware firewall or software firewall. You can allow a packet to go through, and you can see this, by the way, if you download Zone Alarm and play with it. You can allow a packet to go through, you can block it, or you can prompt the user every time to do something, okay? Allow, block, or prompt. And then firewall rules are a set of instructions that you put in the firewall yourself through a console cable, and you can code it in, upload it, and It's a text file, basically, that you can upload. And then once it's set up and restart that router, then those rules are set in place. So here's an example of a web page rule, okay? Rule description, source address, any. Explanation, the source IP address that is of the web server on the internet. Filtering, because the IP address of the web server cannot be known in advance, this rule allows a packet coming from anywhere to enter the network, meaning allowing, web traffic basically to come in. Next rule, destination address equals internal IP address. The destination address and the IP address of the computer on the internal network where the packet's being sent. This rule applies, allows packets directed to this internal computer to pass through, but blocks packets that do not have correct destination address. This would be stopping things like man-in-the-middle attack from occurring. Okay. Port 80, as a rule, indicates which port is open to accept packets. No other ports are open unless indicated. Again, unless your routers are only as smart as you make them. You can have the most expensive router in the world and plug it in and it'd be absolutely worthless if it's not set up right? So that makes sense. And by the way, the class we offer on campus for switching and routing and setting up teach you all of that. And once you learn the language for the console language for setting up rules on a switch or router, it's not real difficult. It's not changed. It won't change for years, probably. Pretty basic stuff. Okay. It's a little learning curve, but not too bad. But Zone Alarm is one for those not familiar with routing at all or any type of routing rules. And I do have if you're interested, I do have a video tutorial I did a while back on setting up a software-based router, firewall, pfSense. It's a Linux-based router that you can set up with a virtual appliance on any network. It doesn't cost anything. So I can send you that if you want that information. Methods of firewall packet filtering. You have stateless filtering and stateful filtering. Stateless is basically inspects every packet coming in, permits or denies based on conditions or the rules you put in the router. Stateful packet filtering keeps record of every connection state, open or closed, and then makes decision on those connections. Web application firewall, we talked a little bit about that already. This allows packets to flow on your network like web browser port 80, which is general web browsing, FTP port 21, Telnet, can block specific sites or known sites that might have issues. It can block script attacks, like SQL scripting injection, XSS scripting injection. It can block proxies from occurring. This is real popular. People will try to bypass firewalls with proxies or VPNs inside the network. You can block that as well in a firewall. And so, because VPNs are going to use certain ports, they're going to use certain tunnels to get out. You can lock your network down to where no tunnels are allowed, but what you allow, if that makes sense. Now, if they want to do that outside the network, that's great. But while they're in your network and they're connected to your network, they're under the umbrella of your firewall, if that makes sense. Just like if you do VPN to work, you might have been explained this from your IT person at work, but when you are VPNing into your workplace, the rules that you have for that internet activity or for that network activity are set by the rules on that firewall and underneath that firewall in your workplace. When you disconnect, you are under whatever rules you might be at that time, whether it be your home or wherever it might be. And so when you're connecting back and forth between VPN, non-VPN, there are certain ports used by VPN, whether it be Cisco VPNs, whether it be any VPN, that can be blocked or allowed in firewalls. Also, proxies used to be really popular to filter network traffic, bypass network traffic. But again, those can be caught as well and blocked. So here's an example of a proxy server. There's literally thousands and thousands of proxy servers out there that people can find that are free, paid, whatever. Much like a VPN, but you're just putting in a proxy IP address in your web browser to bypass filtering. So here you have a normal network with a switch, right? And notice between the switch and the firewall, somebody puts in a proxy, okay? And it could be a real proxy the company uses, or it could be a proxy that maybe an individual behind the firewall is trying to use to bypass the rules set in that firewall, okay? Because if it's configured right and it's not blocked, the firewall is not going to catch any activity because the proxy isn't located where you're seeing it here. It might be located over here in Germany or somewhere, or Canada or somewhere, right? This picture here is showing a proxy a network actually uses for purpose, which is from the outside coming in, all these computers and switches, all the IP addresses will be hidden because of the proxy from the outside. Internally, everybody sees each other is fine. But if you were to try to intercept traffic, a hacker was trying to intercept traffic outside of the proxy line here, like say this one here, they might see this as they will see this as a totally separate IP address than what it really is. And so they can attack that IP address that they see all day long. It's not going to do anything because of the proxy. So here's what it looks like in your web browser to set the proxy. You notice a whole bunch of different proxy protocols can be set. Port 80 proxy for HTTP, secure proxy, port 143, FTP proxy for port 21, SOX proxy, whatever port it might be that's used, say for MySQL or something. Then exceptions, you can say, yeah, so instead of like all traffic going through port 80, you can put a proxy port IP address, and we'll say it's outside of the network, or for the purpose of this argument here, inside the network, but a certain server, this server here has a certain IP address that you put up here in the HTTP portion. So what that does is on this proxy device, every bit of web traffic set up on your network, if the IP address is set here of port 80, it'll go through this proxy server. Every computer will go through the proxy server. So a couple reasons it's used. One is filtering, because you can do proxy filtering, computer networks can do. So every bit of traffic somebody's using on your network can be filtered through that proxy server. Content filtering is the number one reason companies use it, is they filter the content of what people are browsing, if that makes sense. You can also log browsing as well, just pure logging of where people go. Then that's the main reason why companies use it, is to, you could say spy on their employees, but they're really just keeping a log of all the activity. But if they see some red flags, they can also put those red flags in the proxy server rules. Now, can people remove this proxy information from an internet browser? Yes, they can. So that's really not, so really a lot of companies don't do this anymore, because if a hacker knows what they're doing, or even an employee knows what they're doing, they can remove proxy information from a web browser. Just go to Tools, Options, Proxy, and there you go. You can see everything in there and remove it, or add in whatever you want to. Add in another proxy. So instead of this proxy here, which is a company proxy, add an outside third-party proxy, and then bypass this proxy. You don't even see any of your activity on the network, as far as going outside of your network on the internet. So there's tons of third parties. The reason I'm aware of it, in schools anyway, is, again, I taught high school for years, and so high schoolers would use these third-party proxies to bypass the filtering. We used SonicWall filtering at that time, so they would use third-party proxies to put it in their web browser, right, to get to what at that time it was like, I'm trying to think, MySpace. You guys remember MySpace? MySpace, that was the one. That was the before Facebook. Remember MySpace? So everybody at that time, it was really cool to have your own MySpace template. Hey, you guys see my MySpace template? Yeah, you got to get Chuck's MySpace template. It's awesome. And so they would put the proxy in for MySpace, which there's tons of them out there, and then they could get to any MySpace account through that proxy. And until IT found out what that proxy was, it would go for a good day or whatever. And then it would get around to what the proxy was, and then we'd block it. So anyway, that's the fun of being IT in high school. Proxy server advantages, though, there are positives. Speed's a positive. It does increase speeds because requests can be served from a cache, meaning if everybody in here is going through a proxy, and I tell you everybody go to the same website, the first person that goes to that website, it caches it. Everybody else afterwards just views that cache. So instead of loading 20 times that website, it loads it once. So much more efficient on bandwidth in the network, right? It reduces costs because of bandwidth. You don't have to pay a higher premium for bandwidth from your ISP because you're using a proxy. Improved management, again, blocking websites. Net Nanny, you guys heard of Net Nanny before? It's a popular filtering software for home users, for kids, for parents to use. It's a proxy. It's a proxy that you can sign up for, and you basically can do it in your house and go onto your router and put in Net Nanny's IP address and username, password. In fact, a lot of your routers actually have some of these things built in that I'm talking about, where Net Nanny is a feature maybe where you can content filter your activity. But kids today don't really care because they have their own cell phones in the room anyway that doesn't even use a network. So, but anyway, content filtering, management, stronger security, intercepts malware, can hide the client's IP address like I talked about earlier, and it will. So anything here, so say this is a 10.2.0.1 IP or 2. IP address. Okay, it might say that the proxy a hacker's coming in, seeing this computer's activity, it might see it as a 197.20.3.2. And it's trying to attack that computer. It's not going to go anywhere because it's not a real IP address. It's a proxy. It goes nowhere. If that makes sense. So it does hide and stop hacking because of that outside of the network coming in. Reverse proxies. This is not serve clients. It routes incoming requests to correct server. And reverse proxy IP address is visible to outside world. Internal server's IP address would be hidden. So here's an example of what I just talked about earlier on being hidden. So you have on the left side some internal IP addresses, 192.146.118.20. It goes to a web page called 123.org. Notice it goes through the proxy. Notice what IP address it gives it. It's changed. It's a different IP address. So on the source, if it was to be intercepted and man in the middle or some type of attack, it would get a bogus IP address. So instead of the .20, it's a .254. Okay. So the proxy replaces the source IP with its own IP address, then goes through the internet. Reverse proxy serves server routes to the correct server. So it takes this .424, gets the web page from the server, from web server 1, whatever it might be. So it's this one right here. And then it comes back and loads it back through to this computer here to load that web page. Spam filtering, I'll end on this one. This is still the most popular filtering type in business, is spam filtering. 98% of most companies' email is spam, okay? Meaning only 2%, 2 to 3% are real emails, still today. It's the #1 moneymaker in the world is spamming. You say, how does it make money? It's been proven that if people view an email, regardless of what it might be for Cialis or a Vegas trip or whatever it might be, doesn't matter. They view it 3 times and be more likely to buy it. Also, once they purchase something, a lot of times they will immediately share it to all their friends on that network, whatever system they're using. So spam is definitely still big, even with the Anti-Cam Spam Act that came in effect about 10 years ago. It's still huge. That's why companies like Barracuda Firewall, Cisco Firewall for email filtering is really popular because it's a necessity. You have to have it. You have to have it. So what it does is it blocks the spam before it hits the computers, basically. They don't even see it. And so you say, well, is it always right? No, it's not. Okay, so things will be targeted as being spam when they're not spam. So IT's job is to constantly throughout the day move spam from a spam filter to whatever email it's supposed to be going to, right? An example, it happens when you have a new company come on board that's communicating with your people. That company might have been blacklisted at one point for, say, doing a mass mail or something. I don't know, a mass email. So they've been put on a blacklist. Barracuda or Cisco Firewall, whatever one you're using, email filtering system, sees it as a bad domain. It's been marked. Somebody turned it in. Because the way things are turned in, by the way, on spamming, if you send an email from your email address to more than 150 users at one time, you can be put on that list. More than 150 users. Which, if you think about it, that's not a lot of users, right? When it comes to business stuff. But that's why you need to use software like Constant Contact or things like that, to where these folks do this for a living, and they basically allow people to opt into every email they get if it's a marketing type email, right? So that's how you put on a bad list, by the way. So the email system uses two protocols. You've heard of both these probably. SMTP, which is the default port on that's port 25. And then POP, which is the default port on that's 110 in networking. SMTP handles outgoing traffic. POP handles incoming traffic. The other popular one today through Exchange is IMAP. You might have heard of that as well as a popular protocol in email as well. Probably the most popular now. But here's the way spam filtering works. It sits on the server usually as a hardware device, a spam filter, and it listens to all the incoming traffic and outgoing traffic, basically. And specifically, it's looking for, in this case here, port 25 if it's at SMTP. It passes non-spam mail from the SMTP server to another port. This method prevents SMTP server from notifying spammer of failed message delivery. Because if a spammer knows it's a failed message delivery, they'll stop doing it, and then it's unlikely to be caught. This way, it's likely to be caught and added to not only your spam filter, but the way Barracuda and these email filtering companies work with these hardware. After so many people report the same spam, it's then added to that database. That domain's added to that database. But the way marketers work, they have a lot of money, and it's pretty easy to set a new domain easily to create a new email domain. Email domains are created a dime a dozen every day. They just change the email domain and start cycle over again. So here we go. We got email sends, email receive. So email sends, port 25, goes to the SMTP server through the internet. Port 25, spam filter. Port 26, SMTP filter. POP3 server, which is 110, sucks it down to the actual receiver. So spam filters are installed on POP3. All spam must first pass through the SMTP server and be delivered to the user's mailbox. The reason it does POP3 or even IMAP today is because that's the incoming messages into the inbox. It's got to filter that first. So before it gets to the user's inbox, if it is spam, it bypasses it, puts it in a spam domain or a spam filter bucket of some type. It can result in increased costs, definitely. Tons of storage every day for spam, being 97% email. And most companies keep 7 years of email, so that can add up pretty quick. And the reason most companies keep 7 years of email is why do you think? Why do you think most companies have to keep 7 years? Just take a guess.
Tax purposes.
Tax purposes might be one reason, yeah. Any other thing you think of? Huh? Credit might be one. Anybody else think of anything else? So if a company's sued for whatever purpose, say for communication or a job they did, a lot of court proceedings will require original emails during that communication from a company. And so the de facto time frame most companies use save data and keep data for is at least 7 years. So 7 years of email, including their spam email. That has to be saved as well. Even though it's spam and the user doesn't see it, it's got to be saved. So it's not technically deleted. Generally, it's generally just kept and backed up. So there's also third-party entity that can be contracted to filter spam. All email can be directed through that spam filter and can be cleansed before being redirected. Okay, an example. Microsoft, you guys have heard of that company, right? Microsoft 360 is a popular provider of email that you can pay like $5-10 per user in a company, and they will provide not only your email system on the cloud, but all your filtering as well is provided. So you don't have to mess with any of that. You can still control it yourself. You can still go in there as an administrator and control that spam, but it's not hosted on your location, but there is a cost applied to it. So, and generally for most companies, for smaller companies, it's probably cheaper sometimes to do that because they don't have to mess with it. It's not on their servers. They don't have to worry about, viruses and malware issues sometimes because it's taken care of through Microsoft 360, who takes care of that and filters all that. Cool? Awesome. So Thursday when you guys come in, we're going to be doing the lab on the Mac filtering. There is a document in there, N6 lab, that we'll be using, this RTF file, and they'll be doing Wireshark. So when you come in, one of you will be using Wireshark. The other one will be using MAC address filtering. This MAC address spoof changer is what it's called, MAC address changer. What you're going to do is before you do the lab, I will have the person that has Wireshark run Wireshark, make sure you can see the IP address of your neighbor, right? The real IP address of your neighbor. So that person will be starting to browse traffic or whatever on the web. The person that doesn't run Wireshark will be running MAC address changer. We'll apply MAC address changer, start doing some web traffic, right? And then the person run Wireshark will run a second time to see if they can see that same IP address, which they shouldn't be able to, because MAC changer is going to change not only your MAC address, it'll also change your IP address dynamically. So we'll use that on Thursday. So cool. It's supposed to get cold tonight, by the way, with some freezing whatever. So par for the course. Just be careful if you're traveling in the morning. That's what I've heard. So welcome to winter 2019 or snowpocalypse, whatever you want to call it. So, all right, we'll see you Thursday. Oh, make sure, just a reminder on the resume thing downstairs, 1322, starts at 6 o'clock if you want to go to it.